Start the recorder again. And now it has audio. Very good. All right, so we are done with conditional statements. Now, conditional statements are very useful, but they do not capture some of the logic that we need to express in algorithms. Okay, just think about it this way. The conditional statements that we have, I'm going to draw this on the whiteboard, but since the pictures are actually in the notes too, it doesn't, it's going to be okay. If you look at a conditional statement, it looks like this. Okay, it can be more complicated with a multi-branch version, or it can be a simplified version with only one branch doing one action. But in general, it looks like this. Okay, every time you branch, you have to make a decision to go in one or the other direction. But the most important part is what happens after you take one of the two branches. I don't even care which branch you take. You have to get out. Okay? These are all one-way paths. So there's no way to go back to an earlier step using just a conditional statement. Okay? Is repetition important? Not even just in computer algorithms, but in tasks that you perform on a daily basis. Okay, it's kind of important. Okay, I was using the example of parking, finding a parking space and then park your car as an example in my morning class, because they tend to have more problems in the morning with parking, especially before the parking structure was built. Okay, it was really difficult to find a parking spot. So in that case, you cannot just use a conditional statement to express the logic of finding an empty spot to park your car, because sometimes you can go through the entire parking lot and you cannot find a single spot. Then you have to go over the entire thing again to try to find a parking spot. That is a loop, because you are basically going back to square one and redo the same thing all over again. Okay? So when we express algorithms, it's the same thing. Loops are also very, very important when we express algorithms or when we tell the computer how to perform an operation. This is the module. You can read it on your own. I'm not going to read it because I'm going to change the order of how I present the material. Okay? But all the material is still here. So let's think about something that you do on a daily basis, and it is repetitive in its nature. Okay? So what I would do is I'm going to use channel serving when you watch TV as an example. Okay? So let's pretend that this is my TV remote control. It has a power button to turn on the TV. But let's forget about all the other buttons. The only other button that you have is a channel up button. So there's no way to directly dial in the station that you want. Okay? You have to use the channel up button to do your channel serving. Okay? So how do we express the logic of channel serving? Well, let's think about it. I'm going to draw a picture. And the way I'm going to draw the picture in this class is also a little bit different from the way I drew the picture in the morning. The order is a little bit different. You're more than welcome to watch the video of the morning class as well if you want to get a more complete treatment of this particular subject matter. All right, so channel serving. What are important stuff in channel serving or when you watch TV? Are you going to turn on the TV and whatever station or whatever channel it's on, you just kind of keep watching it for the next hour or so?
Depends if it's good.
Okay, very good. Okay, say that again.
Depends if it's good.
Depends on if it's good. Okay. So I'll just go ahead and rephrase what you said a little bit, okay? So the way I'm going to rephrase it is nothing really big and fancy. I'm just going to rephrase it as, is the channel interesting? Okay. Do you want to watch it? Do you want to keep watching it? That's the question. Now, typically when we ask a question like this, the typical answer is yes, no. But in this case, we can also use true, false as an answer. Okay. Is the channel interesting? True. Is the channel interesting? False, instead of yes, no. Okay. So that's a criteria. It's a condition. Because any type of question where there are only two possible answers, which is true and false, is a condition, and we can use it to determine, hey, which way am I going? Okay, so for the time being, I'm just going to post a question here because it seems to be a very important question with respect to what we are trying to do. The action itself, besides turning on the TV, which is the power button, the only action that you can perform is channel up. Press channel up once. Okay, so I'm going to write that action here and say press channel up, and it's implied that you're pressing it only once. Okay, so that's the action. So now you look at the question here, you look at the action here, and do you think that there are times where you would want to press channel up, and other times that you do not want to press channel up? Okay, so we have a branch. Okay, it seems like this is closely related to conditional statements because we are still making decisions. Okay, are we going this way or going the other way? All right, so let's go ahead and draw a part of this picture. This is the entry point of this entire logic here. And every time you see a question, it kind of implies that we can answer one way or another, but depending on the answer, we can also go one way or the other way. So that means sometimes we will end up performing this operation, and other times we are going to branch the other way. Now at this point, I'm not saying what we are going to do in the other direction. What do you think you would do? What do you think the other path is leading?
Stay.
It will get out and it's time to make a popcorn or do the other things, right? When you've got the right channel, so it's time to sit down, maybe turn on your massage chair, so you can relax at the same time, or whatever you do when you watch TV, okay? So the other direction is actually pretty easy to express because we are just getting out of this loop here. We are done, okay? I'm done finding the channel that I want to watch, so it is time to exit. I made one mistake, with this example at this point, because I really should not be asking, is the channel interesting? I should be asking the question of, is the channel boring to be consistent with the loop, that structure that we are talking about? Okay, is the channel boring, or this is not something that you want to watch? How would you label, this is important because we have to label the branches. So how would you label the left branch? Okay, you label this branch true, and naturally you label the other branch false. Okay, we are almost done here. It seems like this is just a conditional statement, except I have not drawn where do we go after you press channel up, which is the most important part of a loop. Okay, that makes it different from a conditional statement. What do you think? It has to go back. Okay, now we know it has to go back now, but where does it go back to?
The conditional statement.
To ask the question again. Very good. Okay, so we have to get back to the point where we ask the question again so that we can reevaluate whether the new channel after you press channel up is something that is boring, because if it is still boring, then you have to press channel up again. So that means my original picture is not entirely correct, because this, oops, not this part here, really should not be a closed path. Instead, it should look like this. Okay. So we have, after you perform that action, you have to go back to that point and ask the question again. Oops, I just bumped my hand. Okay, let's do that again. I guess it's a good, that's the problem with drawing with a mouse. All right, I'm not gonna waste any time, so it will just kind of look ugly here. The biology teacher would just kind of think, there are no digestive system with a loop. No, there are no. Well, I guess if you ask rabbits, there are. Or cows. Yep.
So would this be like a while loop?
This is a while loop. You're absolutely right. This is what we call a pre-checking loop, because we are checking the condition before we perform an action. What I just did was I'm drawing arrows to represent which way paths can go or which way you can go. Because people might think that we can take the first junction and go backwards. But no, that's not the case because you can only go in this direction. So when you are here at this point, you can only go down because you cannot go on go sideways. It's only at this point that you have two possible ways to proceed. One way is to go into here and perform the action. The other way will get you out of the loop because you will just go to the next available statement, whatever it is, and perform that operation. And this is called a pre-checking loop or a while loop because we check the condition before we perform the action. And this is the more common loop. Okay, when you have to think of a loop, this is actually more common than the other type of loop. Are there any questions about this picture? Yep, go ahead.
It's unrelated, but is the worksheet going on?
Ah, very good. I can tell who's still on waitlist. Very good. Yep.
Why did you change it from interesting to boring? Couldn't you just swap different calls?
That is absolutely right. If I say, is the channel interesting, then if I want to preserve the logic, I can just swap the true and the false, and it will still mean pretty much the same thing, assuming you can only label a channel as interesting and boring. Okay. The reason why I swap it is because in C, that's the structure of a while loop. The condition is true means you perform the action and then you go back. In Visual Basic, you have a choice. You can actually do it one way or another because they have do, repeat, and then do while. So they can go either way. But in C and C++, you only have while do, which implies you perform the action and then you go back only when the condition is true. So that's why I had to swap it, because I want to be consistent with the control structure that you'll be learning in the next class. Okay, good question. Yep.
Yeah, just quickly, just to make it clear, one of the conditions is that the channel can only be pressed one way going out.
That is correct. You only have one button to get to the next channel, so you cannot go back. Okay. Now here's another question. What if you turn on the TV, it's Mythbuster, which is what you want to watch already? Would you still press the channel up button according to this logic? No, because you check the condition first. So it is possible that the condition that you're checking is true to begin with, without performing any action. So that way, you basically, if you look at the flow of the logic, you come in here, you get to this junction here, you ask the question, is the channel boring? The answer is no, and then you skip the action altogether, and then you get out of the loop. In other words, with a pre-checking loop, it is possible to perform 0 iterations. Okay? Are there any questions about this picture? Yes?
What if there is no boring channel? I mean, it keeps turning around and around and around.
What if all the channels are boring?
Yeah. Oh,
Then it
okay.
becomes an infinite loop. Then it becomes an infinite loop. And that's why in real life programming, a lot of times it's easy to write an algorithm to solve a problem. It is all the other weird and abnormal and infrequent conditions that are difficult to express, and most of the time people forget to express that logic. It's just like finding a parking spot in the parking lot. Okay, so you can say while cannot find a parking spot, go to the next aisle. Okay, so if the current aisle does not have a does not have a spot to park, go to the next aisle. So that way you will just be circling around the parking lot, in circles, right? What if the time is already past the class that you want to go to? The logic will still be telling you to go around. So in that case, if you want to avoid that kind of problem, you have to express while I cannot find a parking spot and class time is not over yet. Then keep doing it, because if the class time is over, it's time to get out of the parking lot and go home. Are we still doing okay so far with a pre-checking loop? You check the condition, then you perform an action, but after you perform the action, you have to go back and check the condition again. Okay. So if this is done, what we want to do next is to look at the pseudocode that is representing exactly the same logic. Remember, the pseudocode is what we will be using, in this class to express the logic. The picture is only here to help you understand the structure for the first time. But after this, we'll be focusing on pseudocode entirely. So I'm going to move this one a little bit to the side so I have more room for the pseudocode portion. So the pseudocode is really, using English words to somewhat express exactly the same type of logic. So we'll say while the channel is boring, I'm changing the question to a statement because the channel is boring can still be true or false. Okay, it's not a question anymore, but the condition that the channel is boring can still be true or false, but it just reads better this way. And then inside, we express the action that we want to perform, which is press the channel up button. And then I use and while to indicate this is the end of the loop. So are we doing okay so far with associating the picture, which is easy to understand on the left-hand side, with the much more concise representation in pseudocode on the right-hand side? Are we doing okay so far? Okay. Yep, go ahead.
Now you haven't assigned anything to the question yet, right? At the start, you haven't assigned whether it's true or false. So
Because you have to evaluate the condition
but
to
there's
find
no
out whether it's.
statement to evaluate the condition yet.
Say again?
You haven't put an if statement, so.
There are no if
channel-
statements. That's the whole point. It is not an if statement. This is a loop. It is a pre-checking loop.
Right.
This is how we express a pre-checking loop in pseudocode. I'll give you an example, an actual example later, so we can actually trace it and find out, how do we get through a loop like this kind. Okay, well, let's do it now. Let's go ahead and use an example to illustrate the same thing, except in the example, I'm not going to use channel serving. I would actually use variables, numbers, and stuff like that, so it's more relevant to what we are talking about in this class. So I will just start with x gets a value of, well, I can either count up or count down. It doesn't matter what way or another. I'll just go ahead and count up. So x starts with a value of 0, and I'll say while x is less than, I just need to make a point. I don't want to make this like super boring, so I want to terminate maybe 3 times. Okay, 3 iterations is more than enough. Inside, I say x gets x plus 1, and while, and I have to indent the 1 inside because we'll definitely explain why indentation is important in a pseudocode program, or also in any type of program. Indentation is important. So this is the loop, or this is the pseudocode that I want to trace, and just like with conditional statements, we will use an additional sheet to look at the trace. I use a new window to just look at the trace itself. Do you think we need a column for comments? In other words, are we going to evaluate conditions?
Yes.
Yeah, we are going to evaluate conditions, so you need a column, that is called comments, because there's no effect whatsoever that will be observable in the variables. We have line number. We have one single variable in this case, which is x. All right, looking at the pseudocode, do you think it matters one way or another whether x starts with a particular value? No, because the first thing we do to it is an assignment that overwrites its original value completely. Okay, so it doesn't matter what x starts with. So the precondition is, well, we don't really care what x starts with because that's not going to impact the logic of this program or how this particular algorithm performs. Okay, so we'll start with line 1. Line 1 is pretty simple. It's a constant assignment statement. We evaluate the right-hand side. It gives us a value of 0, and then we update the left-hand side with that value. So x ends up with a value of 0. Line 2 is has to evaluate a condition, and that's why I'm going to use the comments column to remember the result of the evaluation. So here we say x is less than 3 is, what do you think? It is true because x at this point has a value of 0. So this is true. And according to the picture, what do we do when the condition is true? Do we get out of the loop? Or do we perform the action specified inside the loop? We perform the operation inside the loop. In this case, line 3 is the only action specified. So we just go to line 3. And what is line 3 going to do? X gets bumped up by 1. Okay, x gets x plus 1. X is currently 0. 0 plus 1 is 1. And then we use 1 to update x. So the new value of x is 1. And then what do we do? Go back to line 2. Okay? We do not trace line 4 because line 4 is just there to separate the body of the loop from what is outside of the loop. So we don't trace line 4. And later on, it will even be more clear why line 4 should not be traced. So we go back to line 2, and x is less than 3 is it true or false?
True.
It is true. But tell me, what am I comparing to 3 this time? 1, that's right, because x was updated to a value of 1 is no longer 0. But 1 is also less than 3, and that's why the expression is still true. Then we go to line 3. X gets bumped up by 1 again. It goes to 2. Then we go back to line 2 and reevaluate the condition. X is now 2. 2 is less than 3 is true. We go into the loop. We go to line 3. Line 3 is going to add 1 to x. X goes from 2 to 3. We go back to line 2. X is less than 3 is false. It is false this time because 3 is less than 3 is false. Okay. And then where do we go? We go to post. Not line 4, we go to post. That is why line 4 is not traced, because if you represent the execution of line 4, then it becomes ambiguous. Because do you mean when you go to line 4, do you mean that you are at the end of the action in the loop? Or do you mean it is the end of the entire loop and you're ready to move on to the next statement? It is not clear. Okay? And that's why we don't even trace it, to avoid that ambiguity. Do we have any questions about this trace? Yep.
So to follow your example from before, the first channel is the one you want to stay at. You follow the loop, so just keep iterating until we get to 3, right?
Well, let me change this, example a little bit, and it will change the behavior of this program. Okay. I'm not going to save it, because these are pretty simple, and since this is all being recorded, you guys can easily retype the whole thing. So I'm going to change the program just a little bit, and you can tell me what the algorithm is going to do. Okay. So I'm going to remove all of this. We'll trace it anyway. Line 1 is going to put a value of 3 into x directly, and then line 2 is going to do the same thing as it always does. It has to compare x to 3 and tell me whether x is less than 3 is true or not. Okay? So we'll go ahead and say x is less than 3 is, it is false. So where do we go next? Post. That's right.
But you're saying 3 is the condition where the program is interested, right?
The program is not interested in anything. The program is only going
The
to...
channel is interesting. So 3 is when the person finds the channel interesting, so they want to stay at that channel, correct?
Not really, because the channel is boring is a
Right.
condition. It can either be true or false.
Right. So here you're not telling me. Here you're basically, from the way I see it, it looks like you're just iterating until you get to a value that the while statement doesn't apply to or it's false.
From the
Right.
perspective of the loop, I'm iterating until the condition is false, just like with the other example. Do you see what I mean?
That's true, but then
Because you have to look at x. You have to look at x is less than 3 as an entire thing. That is the condition of the loop.
Uh-huh.
And as any other condition, it can either be true or false. So this will keep going. I will keep performing, I will keep going to line 3, back to line 2, line 3, back to line 2, until line 2, the condition of line 2 is false. And at that point, I will proceed to whatever statement is after the loop. But that behavior is exactly the same as the previous example. It's just that, in this case, I'm dealing with numbers, and the other one is dealing with, channel serving.
But here you're, for X, and when you start, you're assigning it that value, right?
Yeah.
Right, so in your example, that value is unknown.
No.
Start.
Well, in the other example, it's just an illustration that we do. I'm trying to use something that we do on a daily basis to illustrate the concept of a loop, repetition. But we still have a precondition that the TV has to be on, right? Because otherwise you can press channel up all day long and nothing happens. Yep.
Example 1 assumes human interaction. Example 2 is inputted by the machine.
Yep. But the same thing, but the constant part here is there's an operation that potentially affects the condition.
Yeah.
Yep. So that part is still the same. That part has not changed. So am I answering your question? Are you okay now with the meaning of a
I
post-checking
understand
loop?
the concept, but I just
What am I
think it's a
passing?
little
The
bit
rope?
previous example.
As far as the core concept is concerned, they really should be the same. Because a pre-checking loop is a pre-checking loop. It evaluates the condition. If the condition is true, it performs an action, and then after the action, it goes back to the beginning and re-evaluate the condition. If the condition is false, it just goes out of the loop and continue with whatever is after that. What is different between the two examples is the condition is different, and then the action is different. But as far as the control structure is concerned, they are still the same. Let me just give you one more thing that may actually add to the confusion, but I'll give it a try anyway. Yep.
I have one question. What if there was 18 channels and let's say number 12 was a favorite channel? How would we determine that channel is the true statement?
Okay.
One until number 18.
Okay, there are 18 channels, and channel 12 is the interesting one, the non-boring one, right? So it depends on when you first turn on the TV, when the first time you get to the loop, which channel are you on at that point?
Random. I don't know.
If you're on channel 12 already, which is the channel that is not boring, then the condition that the channel is boring is going to be false, so you won't even perform. I have two recommendations. One is silence scheduler, and then the second one is tasker. Tasker for programmers, silence scheduler for non-programmers. Yes, go ahead. So it depends on which channel you're on at that point. Now, if you're on channel 13, then you are quite unfortunate. Because if you're on channel 13 and the only thing you can do is to bump up the channel, then you will go from 13 to 14, 14 to 15, and then go to 18, and then it wraps around to channel 1, and then will go back to channel 12 eventually. But if you're on channel 12 already, then you won't even press the channel up once, because the channel that you're watching is already not boring, which makes the condition the channel is boring false, and then you get out of the loop.
One more question. So my question really meant, in this equation, x is less than 3, but if x was less than 18, the system would just keep relapsing until it hit 18, and then it would say false.
Yep.
So how does that connect to our equation, how does that specify our interest in television show?
I have no interest whatsoever. Remember, in this class, a lot of times I cannot even tell you whether the algorithm is correct or not. I give you an algorithm, we want to figure out what it's going to do. Okay. So in this case, with this particular algorithm, it won't even go into line 3 once because the condition is false to begin with. Okay. So remember what I said a little bit earlier? I'm going to present something that may even make it even more confusing, but I'm going to do it. Okay, if you look at any pre-checking loop, it's going to look like this. Okay, it's going to have some kind of condition, and I'll just call that condition C in this case. And it's going to have some statement block. I'll just call that statement block 1 here. And while. Now, statement block 1 can be one single line. It can be 20,000 lines. I don't care. Okay, it's just one block of stuff inside between while and end while. Okay, and the overall behavior of this is you evaluate condition C. If condition C is true, you perform this entire block of code, and then you have to go back and re-evaluate condition C. So you keep doing this until condition C evaluates to false. Then you proceed to whatever is after the end while. Then you continue execution with the rest of the program. So what is different between this example using numbers and the previous example using channel serving is C is different and the statement block is different. But it doesn't change the control structure itself, and it doesn't change the path, the shape of the path that we described a little bit earlier. Is that part okay? Okay. So let's move on, or do you guys have any more questions?
No,
Go
I was
ahead.
just going to say, I think the confusion is trying to assign the values as apples and apples. Really, what we're doing on the second example is, think of it like the iteration. The first iteration, it could be channel 18, and that's the first iteration. That could be number 1, second, or 0 in this case when we started with x is 0. The first iteration is 0. It could be channel 18. When you look back, be channel 1. That's the second iteration. So I think you don't compare the numbers, but the loop basically.
The structure is the same. We are just substituting the blocks into different
Correct.
with different stuff. In other words, if you go back and look at this picture here, we are just basically saying this text here can change, this text here can change, but the shape, the overall shape of this thing does not change. In fact, I'll just go ahead and illustrate which part of a while loop does not change, and is always going to be like that. This can change depending on what you're specifying. This can change depending on your loop, but this part does not change. The template of a loop does not change. All pre-checking loops will look like this. All you are changing are the blank spaces, and you can specify different things in place of the blank space. Are we doing okay so far? This is the template. Okay, this is the cookie cutter that will cut out all pre-checking loops, so they all have the same shape. Now, some cookies have chocolate chips. Other cookies have almond. Some may have healthier ingredients, but they all have the same shape. Looks more like pretzel to me. Yep.
Can you code a loop within a loop?
Oh yeah, definitely. When we get to nested statements, then we'll get to see that.
Okay.
We can have conditional statements inside conditional statements. We can have loops inside loops. Yep. All right. So let's just let it soak. When we talk about the next kind of loop. Okay. If I call this kind of loop pre-checking for obvious reasons, because we check the condition first before we perform the action, does it imply that we have another kind of loop? If this is the only kind of loop, I would have just called that loop, right? So the fact that I'm calling this pre-checking loop implies
Post-checking.
Post-checking, very good, because when we have pre, then we have either in, mid, or post. Okay, so with loops, we have a post-checking loop. Okay, now I want to explain why post-checking loops are even useful in cases like this. So let's say you're writing a program that deals with entering zip code. Okay, so you're asking an end user to enter a zip code, but unfortunately, the users that you're dealing with do not always enter zip codes correctly. So sometimes they will give you like 4 digits, other times they'll give you 6 digits, and other times they'll give you invalid zip codes. Okay, so your job is do not let the program proceed until the zip code is correct, okay, or at least it's valid, okay? So you would think, well, we can do that with a loop because I can do something like this. So you can say while zip code is invalid, do ask user to re-enter zip code, and while. It seems like that's how we want to do it. This logic has one little flaw that makes it not really the best way to express that logic. What would be the flaw? What would be the one problem with this expression here? As a pre-checking loop, the pre has to do with that part.
The user never has an option to enter the zip code in the first place.
Exactly.
Yeah, and you never check the validity of the zip code after the.
What am I checking before the first iteration? Before I ask the user to enter a zip code, what am I checking?
If it's valid.
The zip code that they entered?
Yeah, but there's no expression, there's nothing to ask the user to enter a zip code. So to make this work, now I can see what you guys are thinking, because you are thinking, we can just, hey, add another statement here and say ask user to enter zip code the first time, right? Well, that works, okay? This is okay as a logic. But what if the logic that you're dealing with does not only have one single statement to perform, instead it's a big chunk of code? Then you have to replicate, you have to copy and paste the entire code to that portion. In other words, let me just state this in this manner. Okay. The problem has to do with this condition here is determined by this action, which so happens to be exactly the same action that we have in the loop. Are we agreeing on that? Okay. So the solution is easy. Okay, we just take whatever we specify in the loop and we just copy and paste it here. So that will solve the problem. But in this class, as you will hear from me time and again, copy and paste is not a good thing. Okay, every time you copy and paste, you have to ask yourself, do I really have to do it? Or is there a better way to do it so I do not have to copy and paste? Okay. So we don't want to copy and paste at all. Okay, we want to be able to express, ask user to enter zip code only once in the entire logic, and that's why we cannot do it with a pre-checking loop. But there are ways to kind of hack it and make it work, but it's not as natural as the next kind of loop. So let me go ahead and give you the next kind of loop. It's called post-checking for a particular reason. We check the condition after we perform an action. So let's see, magnifier. So here's a post-checking loop. The post-checking loop, basically specifies that I have an action. So I'll just use the zip code, example here. So here we have enter zip code as the action. And then we have a condition. In this case, my condition is the zip code is valid. Yep. Okay, so that's the condition. I'm gonna group these two so I can move it together. Okay, there we go. All right. So we have the two essential elements in a loop here. The only question is, how are we going to arrange these things so that we can express the logic of, well, we first have to enter zip code once so I can determine whether that zip code is valid or not. If that zip code is invalid, I will go back and ask the user to enter a zip code again, check the condition. If it is false, we go back again. Well, we'll keep doing this until the zip code is valid. If zip code is valid, is true, then we'll proceed and do some other processing with the zip code. So that's what I want to do. How do we draw a picture to represent that logic?
Maybe just like the inverse to the other one?
It looks a little bit like the inverse, but it's not exactly like the inverse. It's not the mirror image. So let's take a look here. Where's the branch? Well, I put the condition at the right place, so you already know where the branch is, right? Because we only have a branch, well, we express a condition, we ask a question, only when we have two ways to proceed. So having the condition placed over there means the branch is after the action, okay? And therefore the name post-checking loop. Okay, so let me just draw this picture, gradually. So this is an action. It leads to a certain point where there are two ways to proceed. Okay, so there are two ways to proceed, and somehow we get to the beginning here. We don't know exactly how yet, and this is what we have. Looks like gingerbread boy. Dinner time, just I see food in everything. All right, let's try to label the two legs of our gingerbread boy here. Okay. If I tell you one will get us out of the loop here, let me label which one will get us out of the loop. So let's just say that this one is going to get us out of the loop. How should I label that one? Just looking at the logic here, the zip code is correct. It's getting me out of the loop, so the condition is true. Very good. So this is labeled true, which automatically makes the other one false, because not true is false. All right, excellent. So we are done with a good portion of this loop here. So what do we do when somebody enters a zip code and the zip code is valid, is false, which means it's invalid? What do? We want to ask the user to input it again. All right, so let's go ahead and draw that part of the loop. So we want this to connect back to the beginning here, so we can restart or re-perform the entire operation. Okay, that looks okay. Looks like a very deformed gingerbread boy.
Noble.
Too noble. Okay, but we have one problem here. How do we get into the loop to begin with? There's no entry point to the whole thing, right? Okay, so that means I just have to change my drawing a little bit here and allow an entry point. So we'll just go ahead and do it this way. Here's my entry point, but we also have to specify a path for the action to re-enter to the beginning. So I'm just using arrows here to indicate which ways are one way, and that becomes our post-checking loop. We perform the action first. In this case, the action is enter a zip code, and the condition is the zip code is valid. And this is a post-checking loop instead of a pre-checking loop. This is definitely less common compared to the other form. Okay, most loops I would say are pre-checking loops. Very few, there are very few situations where you have to use a post-checking loop. The only time you have to use a post-checking loop is the condition you're checking needs the action itself, so you have to perform the action at least once in order to ask the question. Are we doing okay so far with this picture? Just like with the other example, after we draw a picture, I'm going to show you the pseudocode representing exactly the same logic. So let me go find my little notepad here. This one is just repeat, and then we have enter zip code until the zip code is valid. And let me just scroll this up so we don't get distraction from the other stuff. That almost reads like English to me. Repeat enter zip code until the zip code is valid. Are we doing okay so far corresponding or associating the picture on the left-hand side with the pseudocode on the right-hand side? Yeah. All right, very good. So now we have the two loops. We have pre-checking loop and then post-checking loop. We'll do one example, just so that we know how to trace a post-checking loop, and then we are done with all the control structures. Okay, we have conditional statements, and then we have two kinds of loops. We are done with control structures. And let's see, get back to the spreadsheet. I'm going to start a new one. And we'll do a countdown this time. Okay, x starts with a higher value, let's say 5, and then we have repeat. X gets x minus 1 until x is less than let me make this one tricky. Okay, we'll do a decrement by 2, and I'll say until x equals to 1. Okay, so this is not tricky yet, but it is a setup for something tricky. All right, so here's my pseudocode, and here I want to do a trace. Are we going to evaluate any conditions?
X.
Definitely yes, right? So we need a comment column because we want to indicate the result of the evaluation of conditions. We have line number, we have one single variable x here. The precondition is, we don't really care what x has, as its value, because the first thing we're going to do is to destroy or overwrite its value, so it doesn't really matter what it had before the algorithm. And we'll go ahead and start with line 1. Line 1's pretty simple. X gets a value of 5. Then we go to, remember, we don't trace any lines that actually do not do anything. And once again, repeat doesn't do anything except to indicate the beginning of the loop. But by itself, it doesn't do anything. So we will not trace line 2. Instead, we'll go straight to line 3. Line 3 is going to decrement x by 2. So from 5, it will get to 3. Then we go to line 4. Line 4 has a condition to evaluate. X equals to 1 is a condition. What is its value? X equals 1 is false because it has a value of 3. Then what do we do? If you go back to the picture, let's go back to the picture here. When the condition is false, what do? We go back, we loop back. Okay, very good. So let's go ahead and loop back. And that means we're going back to which line? Line 3. Yep. Let me answer your question first. Go ahead.
To keep with what was before with the C convention, wouldn't you want to switch it to is it invalid? Or is this messed up?
Yes, because in C you only have do while. I'm borrowing repeat until from Pascal, so you are absolutely right. In C you have to flip the logic, but I think repeat until is more colloquial. We use that more often instead of using do while. We use repeat until. It's like do homework until done, right? We seldom say while not done do homework.
Sure.
Or do homework while not done. Okay, that's it. It works the same way, expresses the same logic, but I think the repeat until works better because the word until is actually used more often, and say you have to keep doing blah 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 until the exit condition. So that's why I pick repeat until in this case, even though it is a diversion from the C standard.
Okay.
Yep. So there's a particular reason why I picked this. Okay. So getting back to here. Now this is the nice thing about having a trace like this, because I can get distracted, when I'm doing a trace, but because I know exactly where I am in the algorithm in terms of the line number, as well as the current value of all the variable, I can continue. I can resume my trace anytime I want. Okay. So that means, it's really a nifty tool if I want to keep track of an algorithm, because I'm not just writing down, numbers on a piece of paper, which I can lose track easily. This is very complete. So now that we are back to line 3, what is line 3 going to do? It's going to decrease the value of x by 2, and x currently has a value of 3, so now it gets down to 1. Then we have to go to line 4 to evaluate the exit condition. X equals to 1 is true. And we are done. We use post to indicate that's the end of this particular algorithm. Nothing tricky, right? What if I change the condition on line 1, or not the condition, but I change the assignment statement on line 1 to say x gets 6 instead? What is it going to do?
0 forever.
It will not stop. Because if it started with a value of 6, the next one is going to be 4, it's going to be 2, and then 0, and then -2, -4. it will never hit 1. Okay, so that's why I call this one tricky, because if I just choose this number carefully, this can become an infinite loop. Okay, so you got to be careful when you use loops, because you don't want to end up with an infinite loop unless that is what you're intending. Do we have any questions about pre-checking loops and post-checking loops?
If we're ever going to be doing stuff like this, do you have a particular, for instance, you chose repeat here, versus we could put a loop, or can we use any type of language in the future?
No, you kind of have to keep the same structure. Well, in fact, in this class, you're not going to write any algorithms. So that is not going to be a major concern.
Isn't this class called algorithms?
But I'm designing. I'm designing, but I'll show you the process, of how it works, which is actually very difficult. I can come up with algorithms, but to explain the process is difficult. If you ask an artist, what goes through your mind, when you draw this painting or make this sculpture, as much as they want to tell you, a lot of times they cannot, because the thinking process, sometimes is indescribable. I mean, there's no way to describe it. So I would try my best to kind of structure my thinking process, like, what steps do I go through in my mind? How do I choose to start with this? Why do I choose to start with something? And from there, where do I go? How do I make the algorithm more, specific? How do I, choose this? Why do I choose that? And so on. So it is, algorithm design, but it's not from your perspective per se, because I want you guys to be really familiar with what elements in the program will do first before you actually write your own program. Okay, which is a slightly different approach from some of the other professors. Remember, there was another student here on the first day, and she was commenting that another professor teaching cisp300 at a different college would use a specific programming language for that particular class. But I do not want to do that, because I want you guys to be able to follow through my code and know exactly what it does. Okay? So you might think the rest of the semester is going to be super boring, because, as I said, we are already done with all the control structures, right? Conditional statement, 2 loops, we're done. Well, if you read ahead of me, let's just go back to the website. And if you read ahead of me, you will see the next one is pre and post condition. That's the heavy-duty math portion. And then we have top-down design. I think, there you go. Then we have top-down design. And then we have arrays and array indexing. And then we have short-circuited Boolean operators and searching in a sorted array. That's binary search, by the way. And then we have subroutines. Okay, and then we have subroutines, and then within subroutines we explain what is a local variable and what are parameters. How do you return a value? That pretty much is the end of the semester, because a lot of this stuff is grayed out after that. We also talk about types and records at the end of the semester. So I'm telling you that this semester will be filled with content, even though we are done with control structures already. There's still plenty of material to go through in this class. Okay, because by combining things, things will. How should I put it? You have ingredient A, and you know it really well. You have ingredient B, you know it really well. But what happens when you mix ingredient A and ingredient B? Okay, and there are a lot of stuff that can happen like that in programming when we combine concepts. So that also is a reason why this class is not going to be that boring, I hope. All right, so we're done with loops and conditional statements. Now it's time to get started with nested statements. And nested statements, let me give you an example first. This is a nested statement. We have seen something like this already. We saw something just like this maybe half an hour ago, right? But it is nested already because line 3 is a statement on its own, but it's nested inside a while loop statement. Line 2, 3, and 4 can be seen as one single statement. It is a pre-checking loop. It is a statement. But within that statement, it is containing another statement, which is an assignment statement, which is our line 3. That is what I mean by nesting. Okay, so we can contain one type of statement within another statement. Now, of course, this one doesn't seem very interesting, but here comes a little more complicated one, which answered the question that somebody asked earlier. Can we have a loop inside a loop? The answer is definitely. Okay, so now that we know what we'll be talking about in this particular module, let's talk about why we have to put, why we need the ability to have one statement inside another statement, and so on. Okay, I'll just try to explain that, the rationale of nesting statements. So to explain that, I'll just give you an example of a hard drive. Okay, hard drives and algorithms, how do they relate? So let's say you just bought a 3 terabyte hard drive from Fry's. How much are those things anyway? $150 bucks can get you, what, 3 terabytes?
It depends if you want USB or one that you put in your computer.
Yeah, just say the internal drive.
It's a little cheaper. I'd say probably about 100. You get 4 for about 150.
Wow, that is cheap. I remember I paid $200 for a 20 megabyte hard drive. That kind of tells you, when I started to mess around with computers. Yeah, 20 megabytes. I mean, that's like the largest, highest capacity hard drive of the time. Now it won't even hold one single file, right? I mean, one single picture is like, oh, okay, that's more than 20 megabytes. All right. So let's say you just bought a 3 terabyte hard drive. And I give you one restriction. You cannot have folders. Every file has to go to the root directory of the entire drive. D:\/ is all that you have. But you still have 3 terabytes. Okay, why are you guys giving me that response? What is so funny about it?
Find anything.
You won't be able to find anything because it is not organized, right? And that's why, in an office we have folders, we have filing cabinets, and then we have, different ways of organizing things. Okay, it's the same way here. Statements, except for assignment statements, the other 3 types of statements are containers. Okay, because they can contain other statements. Are we doing okay so far? Okay, so let's go ahead and just look at one example of a nested statement or an algorithm with nested statements. And we'll go ahead and do another trace. Okay, so let's go ahead and write another algorithm in a spreadsheet. And let me think about what to do with this one. Okay, I know what. Okay, so x gets 0 while x is less than, let's say 5. Okay. The do part is kind of optional. I just add a do here because in Pascal there's always a do. And inside I would use a conditional statement. I'll say if x equals to 2, then y gets y plus 1, else if, let's see, what should I do here? Okay, let's make this tricky. If x divided by 2 equals to 1, then z gets z plus 1, and if x gets x plus 1, and while. Okay, first problem. I can't really see which statement is containing which statement. Not visually. Okay, yep, go ahead.
Oh, no, I was just trying to.
Yeah, you can kind of analyze it, right? Because you can say, oh, a while has to be ended with and while. Okay, so everything in between would be stuff that you do inside the while loop. Okay, and inside the while loop we have an if here. Now this if needs an and, if, but I have two and ifs here. Which and if is ending this if? Well, it is a sandwich. It's like parentheses, right? Okay, so this if has to be matched by the last and if, not the second last. So this if is ended by this and if here. That means this if is ended with this particular and if, and these are statements that are just completely contained in the other ones. Okay, so once you know how to read it, yes, you can figure it out, but is it easy? Not too hard with the 11-line programs. What if this is 500 lines with 6 levels of nesting? It can get a little bit difficult, okay, to read it. And that's why we want indentation. This is why indentation is helpful. And in this case, because this is a spreadsheet, I can do indentations like this, which is really, really helpful because I can select the lines that I want to indent and indent the entire block at a time. So this guy needs one more indentation. What about this? Is it a little bit easier to read? It's just like when you explore a file folder, it can display the subfolders, but it has the indentation to show you that these are subfolders of this folder, and then those are subfolders of this particular folder, and so on. So the indentation shows you clearly and visually what is nested within what else. Okay. Let's go ahead and see what we are going to do here and take a look at what the program is going to do. So we'll go ahead and trace it. Did I open a new window? Oh, I did, but I got too many windows open, so it's getting a little bit confusing. There we go. Okay, so we have comments because we definitely have conditions to evaluate. We have line number, we have 2 variables, 3, x, y, and z. Two of these have to start with a value because otherwise the algorithm won't work. X is the only one that can start with an unknown value, so we'll put a question mark here. And this is my precondition. It's all getting recorded, so I wouldn't worry too much about copying everything. So I would just I would focus on the example, but I would write down really tricky parts. Okay, something that is really tricky, something that is not something that you were expecting. That is what I would write down. Okay. Line 1, simple. X gets initialized to 0. Line 2 is a while loop, and the condition in this case is x is less than 5. Is that true or false? It is true. Okay, very good. Okay, now where do we go? We have to go inside the loop. What is the first statement inside the loop?
How do you know y and z are 0? How do you know y and z are 0?
It's just given, so I don't need assignment statements to deal with those. So in this case, the precondition is given to you.
Okay.
There's no particular reason why that is the case. Okay, so after line 2, where do we go?
Okay.
Line 3, that's still not very difficult. Line 3 is the beginning of a conditional statement, so we have to evaluate the condition of the conditional statement. In this case, it's x equals 2. Is that true or false?
False.
It is false. And then where do we go?
Line 6.
We go to line 6. Very good, because the then portion of this conditional statement is line 4. The else portion of this conditional statement, which is the outer conditional statement, is line 6 to line 8. Okay? In other words, if you look at, this is the beginning of the conditional statement. This is what you do when the condition is true. This is what you do when the condition is false. Okay? Yep.
Sorry, soft subject. How do you get those numbers?
the numbers?
Yeah, just when you just highlighting it, it's just auto.
Yeah, you just highlight one and then you grab this lower right-hand corner, and then you drag it and it will automatically number the cells accordingly. Okay, so after line 3, where do we go? After line 3, we go to line 6. Line 6 is the beginning of another conditional statement. And this time the conditional statement is x divided by 2 equals to 1. X is 0. 0 divided by 2 is 0. 0 equals to 1 is false. Okay, so we say x divided by 2 equals 1 is false. Then where do we go? That's a good question there, right? We go to line 10. That's right. There's nothing to do. Okay, we actually exit multiple statements at the same time. Okay, we skip all the way to line 10. Line 10 is adding 1 to x. X becomes 1. And then where do we go? We're at the end of a loop. So what do we do at the end of a loop? We go back to the beginning. This is a pre-checking loop. So we go back to line 2. Line 2 checks whether x is less than 5. It is still true. Then we go back to line 3. X equals to 2 is false. So nothing really gets changed at this point, but the next iteration is going to be more fun. So line 6 evaluates x divided by 2 equals 1. That is false. We are just going to use the usual division. So 1 divided by 2 is 0.5. 0.5 equals 1 is false. Then we go to line 10 again. Now x bumps up to 2. Now we have to be careful. Okay, this iteration is one that we have to be careful about. We go back to line 2, beginning of the loop. Reevaluate the condition, x is less than 5. It is still true because x is 2. Then we go to line 3. This is easy. X equals 2 is true because x is exactly 2. Then where do we go? We go to line 4. And line 4 is going to do something to y. Y gets y plus 1, so it goes from 0 to 1. And then what do we do?
Line 10.
We go to line 10. Okay? We go to line 10 because line 4 is the only thing that we have to do when the condition x equals 2 is true. So we don't bother with the else portion of the outer conditional statement. So we don't even check whether x divided by 2 is 1. All right? So the next line is line 10. After line 10, line 10 is going to add 1 to x. X goes from 2 to 3. Then we go back to line 2, and so on. Okay, so I can see that some people are doing like, okay, I can't follow this. Okay? Now, at the beginning of a semester, if you cannot follow a logic like this, one thing you can do is to draw a picture. Okay? But this picture is going to be a little bit messy. It's going to be a little bit messy. So I'm just thinking, should I use an actual picture or should I use, just go ahead and use a picture. So for those of you who want to capture this, you might need to take your phone out and take a picture of the whiteboard. I can do that too. I have my cell phone too, so I can just take a picture when I'm done. But focus on the process, okay? So don't just try to copy everything. Focus on the process. Yep.
So would this be a bug in the code in the fact that you would never actually evaluate z because you're never going to get to 6? Because x being 2, you're going to skip over that every time.
You
Does
can
that make
only
sense?
you can call something a bug only if you know the expected behavior.
Okay.
But since I never tell you what the program is expected to do, all we are trying to do is to just look at the code here and figure out what it is going to do.
Okay.
So we are using a very Buddhist, attitude here. We're not judging whether the algorithm is right or wrong. We're just saying, it is what it is. We just want to figure out what it's going to do.
Okay.
That is the path. Okay, that was another hand.
I was just going to say, it would be more like a dead branch than a bug. Yeah.
Yeah, it is called a dead branch because it will never be exercised.
Yeah.
That is correct. Okay, so when you draw the picture, this is what you need to do is to focus on the approach. Don't focus on the detail and try to copy everything, okay? Focus on the approach. What we will do is to say, okay, we have one single statement before everything else, okay? So you draw that little statement here. X gets initialized to 0, okay? And then we have a second statement. The second statement is rather big because it is a loop itself. So you look at this mess here and go like, oh man, how do we deal with something like this? Well, it's easy because you know it's a pre-checking loop. You draw a pre-checking loop. That's all you're going to do. Forget about what's inside the pre-checking loop. Just focus on the fact that this is just a pre-checking loop. So we already know what a pre-checking loop looks like. Okay, there's a way to go back, and there's a place where you can branch out to get to the end of the loop here. So I'm leaving a lot of space here because I know there's a lot of stuff inside, and we know there's a condition we have to evaluate. And if the condition is true, we can have a block of code to execute inside the while loop here. At the end of this action, we go back and reevaluate the condition. I focus on just the outermost portion. Is that okay? It's like Russian doll. Okay, you only focus on one layer at a time. You don't worry how much stuff is inside. We don't need to know that until we get to the inside. Okay, so this is the general shape of any pre-checking loop. Now we just have to specify the details. The condition here is x is less than 5, and then we have to try to specify what is inside. Okay, so that means our focus is no longer from line 2 to line 11. Now we can focus on just the content inside the loop itself. We are not looking at the overall folder anymore. We are now looking into the content within the folder. How many statements do we have from line 3 to line 10 at the top level? How many statements are we dealing with? 2 statements. We have one conditional statement and one assignment statement. In other words, you look at line 3 to line 9 and say, oh, that's one conditional statement. Then you look at line 10, which is outside of the conditional statement, as one other statement. So there are only 2 statements. The first statement is a conditional statement. I'm just trying to look at this and try to figure out how much space I need to leave myself. So here's a conditional statement. And it's kind of lopsided because one side is a little bit bigger than the other side. So I'm going to leave myself a little bit more space on one side compared to the other side. And here we have the conditional statement. And then we have one regular assignment statement after that. And that's just x gets x plus 1. We'll express that first. OK, so now we have the conditional statement. With a conditional statement, the first thing we want to express is the condition itself, x equals to 2. Okay? Then we can focus on each branch of the conditional statement. The true branch of the conditional statement is line 4. Okay? Line 4 is y gets y plus 1. And then the false branch is what is the range of lines corresponding to the false side of this conditional statement. It will be line 6 to line 8. Okay? Line 6 to line 8 is the other portion. Line 6 to line 8 is what kind of a statement? It starts with the if, so it's a conditional statement. Okay? So any conditional statement is going to look like this, right? You have 2 branches, and the 2 branches will merge at the end, and then you have a condition. So you can see how I'm doing this just layer by layer instead of trying to figure out the whole thing in one swoop from just doing it sequentially. I'm doing it structurally. So we're dealing with the innermost conditional statement. On line 6, the condition specifies x divided by 2 equals 1. That's the condition. The then branch of line 6 to line 8 is z gets z plus 1. Z gets z plus 1 is the true branch. Oh, but this is tricky. It doesn't have an else. So what do we do when the condition is false? Absolutely nothing. Just leave it like this. It's perfectly okay. Okay? So when the condition is false, we simply say, well, there's nothing to do. That is the structure of that code. And you can see now how we can have one statement containing another statement. Because the outermost portion is a pre-checking loop. But the pre-checking loop is containing a conditional statement, which is this portion here, and an assignment statement. Within the conditional statement, the then branch is a simple assignment statement, but the else branch is a conditional statement itself. So are we doing okay so far? I know this is kind of tedious and cumbersome, but I want to do this at least once, just so that you know the process of looking at nested statements and try to interpret what you're going to do with it. Are we doing okay so far? We are running out of time. I did not finish this entire algorithm, so one thing you can do is to try to finish it up, just to figure out what lines will execute and how will the variables change. We kind of know already because you guys already pointed out that certain branches are called a dead branch, which means we'll never get to that. But nonetheless, it's still good exercise just to go through that code, knowing this picture. And I will take a picture myself and post it online so that you guys have a reference if you want to look at the picture. Oh, okay, someone beat me to it. If you guys want to, you can also, if you want to videotape, stuff, that's okay with me too. It's just that, doing it by hand may get a lot of camera shake. So I'll be seeing tripods next time.